Welcome back, geometry students. We're on section 10.6 in your student journals, page 305. All right, so we're kind of approaching the end of this unit. There are actually quite a few more different properties about circles. I bet you never knew that there was this many different rules about circles. And so there's going to be quite a bit of, to be honest with you, I think it's a little bit confusing on some of these things with all these different theorems. So you're definitely going to want to practice some of these skills. And so this is where we're going to kind of get into a little bit more of, some of our quadratics that I know that some of us are better at than others, but we'll kind of walk through it. So no worries. All right, so we're going to talk about segments of a chord. We're going to talk about tangent segments, secant segments, and external segments. So again, lots of different things that we're going to kind of talk about in this section. So let's kind of get to it. So in this first one, we're talking about, this first theorem is segments of a chord theorem. So we talked about in the last unit, or the last section, about like the angles, the relationship when two lines intersect inside of a circle, what we know about the relationship between this angle. So remember, that was the angle would be half the measure of the sum of the intersected arcs. Now we're going to kind of talk more about segments. So less about angles and more about segments. So what they're saying here is if we have two lines that intersect inside of a circle, the relationship between all the pieces, so like for example, E to A times E to B, so those two pieces of that segment is going to equal the same thing as E to C times E to D. So what we're getting at here is that when we have those two lines that intersect inside of our circle, the segments are proportionate. So the segments have kind of this relationship. So let me give you an example because I think it'd be easier to kind of walk through an example. So let's go to a circle. Let's have two lines that intersect inside of our circle. Okay. So let's say, for example, again, we're talking about segments, not angles here. So we're going to kind of label some of this stuff. So let's say I had this information. So what I'm getting at is this times this. So 8 times x has to equal 10 times 12. So those two pieces have to equal the product of these two pieces have to equal the product of those two pieces. So 8x is going to equal 120. Divide both sides by 8. I get x to equal 15. And so that's that first theorem. And again, it's kind of relating back to that same kind of thing we talked about in 10.5, but now we're talking about segments rather than angles. All right, let's do some more. So we got a few more different theorems. So the next one is called tangent segment and secant segment. So it says a tangent segment is a segment that is tangent to a circle at an endpoint, right? So we have this tangent segment. And a secant segment is a segment that contains a chord of a circle and has exactly one endpoint outside the circle. So this is an external, this is a secant segment. In other words, it passes through the circle in 2 points, but it has exactly one endpoint outside the circle. Okay, so the part of the secant segment that is outside the circle is called the external segment. So basically what they're getting at is we have, this piece of our segment, and then we have this piece that's inside. And then of course we have this tangent piece as well. So there's this relationship that we know about all three of those little pieces. So first of all, P to S, so this distance, this line segment PS is called our tangent segment. P to R is called our secant segment. So this whole distance here, this PR, is called our secant segment. So again, secant means that it intersects the circle in 2 spots. We're calling it a secant segment because it's not a line, right? So it's not going all the way through. And then PQ is the part of that segment that's on the outside of your circle. So we say PQ is the external segment. Okay, so knowing that vocab, there are some theorems that I want to talk about with this. So this one is called segments of secant theorem. So if two secant segments, so again, two segments that kind of have a piece that's inside, so these are our inside pieces, and then we have our outside pieces. So remember, our secant segment would be this whole length here and this whole length here. So it says if two secant segments share the same endpoint outside of a circle, then the product of the lengths of one secant segment and its external segment equals the product of the length of the other secant segment and its external segment. Okay, So let me give you a diagram because I think that one is a little bit hard to kind of understand. So we have two secant segments. So in other words, we have two segments that intersect our circle in two pieces. So let's label this 3 and this 9 and this 4 and this x. So what they're getting at here is that we know there's a relationship between all of these pieces. So these are the external pieces. This whole thing here, so this is 12, and this whole thing here is 4 plus x. So our external, so these are called our secant segments. So 12 and 4 plus x are called our secant segments. In other words, it's that whole length here. So I just added 9 and 3, and then I added 4 plus x. So the relationship is, if you multiply the external segment, so 3, times the secant segment, okay, times 12, it has to equal this external segment times its secant segment. So it gets a little crazy, right? So it's this outside piece times the whole thing equals this outside piece times the whole. All right, so we get 36 equals 4 times 4 plus x. I'm going to go ahead and divide both sides by 4 rather than distribute, just so I can kind of clean things up here a little bit. And then I'm going to subtract 4, so I get x to equal 5. And so in this case, we're just solving for x. We're not actually solving for anything else, like no angle or anything like that. So then I'm finished. So this is that two secant segments. So again, both of these segments intersect my circle in two spots. So this outside piece times the whole thing equals this outside piece times the whole thing. All right, let's look at the next theorem. And then we'll kind of put a bunch of these together. So segments of secants and tangents theorem. All right, so on this one it says, if a secant segment, so again, here's my secant segment. So this whole thing here is my secant segment. And a tangent segment, that's this piece right here, because it's just tangents, not secant, so it doesn't hit it in two spots. Share an point outside the circle, okay? Then the product of the lengths of the secant segment and its external segment equals the square of the length of the tangent segment. Okay, so what they're getting at is they're saying that, again, kind of similarly to the last piece, they're saying this external piece here times this whole thing here, so the outside piece times the whole thing, equals this piece squared. Okay, let me show you what that looks like, because again, that one's kind of a weird one. So we have a tangent segment, so again, hits it in once, kind of hits the circle in one spot, and then we have a secant segment, so it hits it in two spots. So let's say I have this, we'll call this x, we'll call this piece 12, we'll call this piece 15. So what we know about this relationship, we know that 12 times this whole thing, so 12 plus 15 is what? 27, okay? So we know 12 times the whole thing, which is 27, has to equal this segment, which is x, squared. So this external piece here times the whole thing, so 12 times 27, has to equal this tangent piece squared. So 12 times 27, let's do it in our calculator, I get 324, and then I'm going to square root both sides. Remember, we're only taking the positive version of the square root. Normally we put plus and minus, but we're taking the positive version because we're talking about a piece of a circle, right? We're talking about length. So that length would be 18. So again, it's this outside piece times the whole thing of the secant segment equals this tangent piece squared. All right, let's move on. So those were our theorems that we wanted to chat about. What we're going to do now is we're going to kind of put them all together, and we're going to go through a few examples with you. So hopefully this will kind of make some more sense and that you'll understand kind of all these different theorems. All right, so this is that kind of the first couple theorems that we talked about. So we have two lines that intersect inside of a circle. And again, we're talking about the segments here. So what we know is the product of each of those pieces. So x times x plus 1 has to equal, and then 6 times 5. So again, we're looking at this piece times this piece has to equal this piece times this piece. So now we can just kind of multiply through. So x squared plus x equals 30. this is where some of your quadratics are going to come into play. Notice this is a quadratic because there's an x squared, but there's also an x. So in order to solve this quadratic, I need you to set it equal to 0. In other words, move that 30 over, and then I want you to factor and solve. So to factor a trinomial, you set up your two parentheses. Next, what you do is you say, okay, what two things multiply together to give me x squared? So obviously in this case, it would be x and x. Then if you remember this from Algebra 1, we're looking for numbers that multiply to negative 30, but add to positive 1. So they have to multiply to this last value here, but add to the middle term. So let's think about numbers that multiply to negative 30. So that's 1 and 30, 2 and 15, 3 and 10, 5 and 6 would work, right? So which one of those could we possibly pick that would add, so multiply to negative 30 but add to positive 1? I got positive 6 and negative 5 because they multiply to negative 30 but add to positive 1. All right, finish solving. So to solve, you take each of those factors, so each of those parentheses, set it equal to 0 and solve for x. So I get x equal negative 6 and x equal 5. All right, we're talking about a length of a part of a circle, right? So I cannot use that measurement. That doesn't make sense. I'm not going to have a negative 6 length. So my only reasonable answer here is x equals 5. All right, let's do number 2. So again, similarly, same kind of idea. We're going to talk about each of those pieces. So 10 times 7x has to equal 15 times 5x minus 2. So that's the setup. So when you're showing work for this, I do want to see all your work, right? I want to see your process here because these are getting a little bit more complicated. You're not able, I'm not expecting you or don't want you to necessarily do these in your head. I want to see your work kind of laid out. All right, so let's go ahead. 10 times 7x is 70x equals, this would be 15 times 5 is 75, and then minus 30. So this is not quadratic, and the reason I know is because there's no x squared. So I'm just going to go ahead and subtract 75 from both sides, and then divide, divide by negative 5. And so I get x to equal 6. All right, let's look at the next one, number 3. So this is now we're talking about and it's really hard to read this one, I'll be honest. This one is a secant and secant. So they're telling you that this little piece here is 1, and this piece here is x plus 2, and then they're giving you the other secant line. It kind of looks like it was tangent, but it's not. So if you remember the secant, if you have two lines that are secant to the same, that are secant segments, then what you do is you look at this external piece here, so x plus 2, times the whole thing. So this whole thing is 1 plus x plus 2. So this external piece here multiplied by this whole thing. So it's 1 plus x plus 2. It has to equal the same thing on the other side. 2 times this whole thing here. So that would be 2 plus x plus 3. So that setup is really kind of crazy. So that's what I need us to kind of remember to do here. So it's this external piece times the whole thing, and then equals this external piece times the whole thing. So again, to get this whole thing, you're adding like x plus 3 plus 2. Like you're adding both of those pieces together. So let's clean this up a little bit. So this is x plus 2, and then 1 plus x plus 2 gives me x plus 3. And then over here I have 2, and then this would give me x plus 5. So I just combined some like terms. So this is going to be where you're going to FOIL. So remember how we had like the two parentheses here? So I want you to distribute. So this would be x squared plus 3x plus 2x plus 6. And if I distribute here, it'd be 2x plus 10. Let's combine some like terms. So I'm just going to add my 3 and 2x together. Notice that it's quadratic. There's an x squared. So we want to set everything equal to 0. So let's subtract 2x and subtract 10. So if I subtract 2x, I get 3x. If I subtract 10, I get negative 4. So now I have x squared plus 3x minus 4. All right, we are solving, which means you need to factor, set it equal to 0. All right, two values that multiply together to give me x squared, that's x and x. Numbers that multiply together to give me negative 4, but add to positive 3. So that's positive 4 and negative 1. Multiply to negative 4, add to positive 3. Set each of those equal to 0, so I get x to equal negative 4, and then I get this one over here, I would get x to equal 1. There's only one reasonable answer. We're not going to have a length to be a negative, so my only answer here is x equals 1. All right, let's do number 4. So this one's the other one. This is the one where it's tangent, and then we have the external piece and the whole secant segment. Okay, so this would be x minus 1 plus 5, or in other words, x plus 4. So this whole thing here is x plus 4. So if you remember this rule, it was the tangent piece, so x plus 1 squared, has to equal this external piece, x minus 1, times the whole thing, which is x plus 4. So let me do that one again, because these are getting a little tricky. So this external, or this tangent piece here, squared, has to equal the external piece here times the whole thing. So we figured out that whole thing was x plus 4. Now you have to distribute. So remember when you square this, when you square binomial, you are not just distributing the squared. You are foiling. So if I distribute this, I get x squared plus 1x plus 1x plus 1. And on this side, I would get x squared plus 4x minus x minus 4. And I just distributed through the x and through the negative 1 on this side. Let's combine some like terms. So I get x squared plus 2x plus 1. And on this side, I would get x squared plus 3x minus 4. Notice this is quadratic. Go ahead and let's subtract x squared from both sides. Notice what happens when I do that. My x squareds cancel out. So I'm left with 2x plus 1 equals 3x minus 4. Let's go ahead and solve for x. So I'm going to subtract 2x. So I get that. And if I add 4, I get x to equal 5. All right. Like I said, these get a little tricky. So it's kind of important that you're practicing these skills. So obviously the setup here is a little bit more advanced. The math here is a little bit more advanced. We're looking at quadratics. There's one additional problem I would like you to do. Okay, so if you grab a piece of paper for me, please. This is just from section 10.6. This is just kind of an extra example that we're going to talk about in class that I want to make sure that I talk about on the video as well. All right, so let's talk about a circle, and let's talk about either the diameter or the radius. I'm just going to call those both my radius of my circle. So there's a scenario in which I have this external piece and then this tangent piece. So this is kind of a variation of kind of that last theorem we were talking about. So we have its tangent piece, and then we have a secant line, okay? So what you're going to see is this, we're going to use this scenario when it comes to like story problems, right? So this is just kind of the same scenario as our last problem where we had a tangent line and then this external piece. So our secant, this is our external piece. Our secant segment is this whole thing here. So let's add it together. So we have r plus 1. Well, r plus 1 is equal to 2r plus 1. So this is that whole segment here. We call this our secant segment. This is we'll call this our tangent segment. Okay, so this is our tangent segment. So our tangent segment, our secant segment. So the relationship is our tangent segment squared, so 3 squared, is equal to the external piece times this whole thing. So this length here, so 3 squared, which is our tangent piece, is equal to the external piece times the whole thing. So 1 times 2r plus 1. So let's distribute. So I get 9, and then if you multiply by, you just get the same thing, right? So subtract 1, divide by 2, I get my radius, or my r, to equal 4. Okay, like I said, I know this is a little bit trickier. I do absolutely want you to practice this, so please practice this on Big Ideas. Come to class with questions. All right, bye for now.